Hello there everybody. In this video we are going to be looking at solving radical equations. So we've solved linear equations before in the past. In order to do that, we had to do the opposite of what was happening. So like to undo addition, we did subtraction. To undo multiplication, we did division. All right, but what are we going to do when we need to solve radical equations? When the variable that we're trying to solve for is trapped underneath some radical, whether it's a square root, cubed root, whatever, our variable's trapped underneath a radical. What can we do to get that x by itself? Okay, so one way to think about it is the square root of x equals 7. Like if we look at this first example. The square root of x is the same thing as x to the 1/2 power equals 7. All right, so one way I want you to think about it is what could I raise both sides to in order to get this x by itself, in order to get the x to just have an exponent of 1? All right, well, if x is currently being raised to the 1/2 power, then if I square that side, 1/2 times 2, these are going to cancel each other out, leaving me just with x equals 7 squared, or 49. Okay, so what that means is when I take the square root of both sides, remember there's a root of 2 here. We don't write it, but the square root has a root of 2. Okay, so what I'm going to do is I'm going to square both sides. And when I square both sides, the squaring is going to cancel out the square root, or the radical there, and I get x equals 7 squared, or x equals 49. So to undo square roots, we are going to square both sides. Okay, let's move on. Now that we've got that idea, so to undo, maybe to summarize, to undo square root, square both sides. All right, now let's solve some other radicals. Here, we get a square root, okay? So I'm going to square both sides. The square is going to cancel out the square root, leave me just with 5x minus 4 equals 4 squared, which is 16. Now, we know how to solve these. I'm going to add 4 to both sides, so I get 5x equals 20. Divide both sides by 5, and we get x equals 4. Okay, now, we need to get used to checking our answers. So if x is equal to 4, we got 5 times 4 minus 4. 5 times 4 is 20. 20 minus 4 is 16. Square root of 16 is 4. So this works out, all right, but we have to make sure we're checking our answer. Even if we're checking it in our calculator, that's fine. Just check that x to make sure that it works. All right, let's go on to another one. So here, I don't want to square both sides right away, all right, because my radical isn't by itself yet. First thing I'm going to need to do is add 9 to both sides to get that radical by itself. So then I get square root of x plus 4 equals 12. Now that the radical is by itself, I can square both sides. Squaring is going to cancel out the square root, so we get x plus 4 equals 144. 12 squared is 144. Subtract 4 from both sides, we'll get x equals 140. Then I'm just going to take that and I'm going to plug it into my calculator and make sure it works. So 140 plus 4 is 144. Square root of 144 is 12. 12 minus 9 is 3. It works. Moving on to D. Here we've got a square root on both sides. All right, they're already isolated, so I'm just going to square both sides. The squaring is going to cancel out the square root, and I'm going to be left with what's underneath the radicals, so 2x minus 3 equals negative x plus 9. So I'm going to add x to both sides, so I'll get 3x minus 3 equals 9. Add 3 to both sides, so 3x equals 12. Divide both sides by 3, x equals 4. Then I'm going to use my calculator and I'm going to double check this. So the first radical, 2 times 4 is 8. 8 minus 3 is 5. So the left-hand radical simplifies to the square root of 5. Now, that is not a nice answer. That's not a nice whole number, so I'm just going to leave it as square root of 5. And on the right hand, we get negative x, so negative 4 plus 9, which is 5. So that's the square root of 5. These are equal to each other. So x equals 4 is the correct answer. All right. And then last one we're talking about square roots is part E. The square root of x plus 12 equals 4 times the square root of x. Now, here is a slight issue. All right. There's no way to get the radicals by themselves, right? There's this 4 that's in front of this square root of x. All right, so we can square both sides. All right, we can square both sides here. And let's see what's going to happen. So we're going to square this side. That's going to leave us with just x plus 12. All right, but when I square the right-hand side, if I square 4 square roots of x squared, that's the same thing as 4 square roots of x times 4 square roots of x. All right, just think, power to a power, I have to distribute this exponent to both parts. So I need to make sure that you understand that you're taking that entire right-hand side and squaring it. Because 4 squared, or 4 times 4 is 16, and square root of x times square root of x is just x, because that exponent of 2 is going to cancel out the square root. All right, so 4 square roots of x, that whole thing squared, is going to give me 16x. Okay, so then I subtract x from both sides, and I get 12 equals 15x. So then x equals 12 over 15. All right, so x equals 12 over 15. I can simplify this fraction. I can divide a 3 out of each of them, and I'll get 4/5. So x equals 4/5, or if you want the decimal answer, that's going to be 0.8. All right, so couple key things there. To undo square root, you need to square both sides. All right, and then you want to get the radical by itself, but if you can't get the radical by itself, like in part E, just make sure that when you're squaring both sides, you are doing so correctly. All right, you're not leaving anything out. All right, so those are square roots. To undo a square root, you square both sides. What about other radicals? Like if we have different roots here. Like what about an example 2a? This is the cubed root of 2x plus 7 equals 3. What do you think we need to, what power do we need to raise both sides to? All right, well, because this has a root of 3, I'm going to raise both sides to the third power. All right, to undo a cubed root, we need to cube it. So that's going to cancel that out and leave me just with 2x plus 7, what's underneath that radical. And then 3 cubed, 3 times 3 times 3, is going to give me 27. So now that we're done with the radicals, now we can solve this. Subtract 7 from both sides, so I get 2x equals 20. Divide both sides by 2, I get x equals 10. Very good. So to undo a cubed root, we need to raise both powers, or both sides to the third power. All right, what about in B? We've got 4 times the fifth root of 2x plus 3 minus 5 equals 11. Well, our goal should still be, we got to get this radical by itself before we try to undo that radical, if at all possible. All right, which we can. We can add 5 to both sides. So then we get 4 times the fifth root of 2x plus 3 equals 16. Divide both sides by 4. So we get the fifth root of 2x plus 3 equals 4. All right, now we are going to raise both sides to the fifth power because we need to undo this root of 5. All right, so that's going to cancel out the radical, leave you just with 2x plus 3 equals 4 to the 5th. I don't know that off my top of my head, so I'm going to use my calculator. 4 to the 5th is 1,024. All right, so then I'm going to subtract 3 from both sides. So I'll get 2x equals 1,021. Divide both sides by 2, and I'll get x equals 510.5. All right, or if you did just the calculator, if you didn't use your calculator, 1,021 divided by 2. So either of those answers works. Okay, so that's how you undo radicals. All right, whether it's a square root, cubed root, fourth root, fifth root, doesn't matter. And then we've got these answers. We can always plug them back in. So if I plug in the fourth root, or if I plug in 510.5 for x, 2 times 510.5 plus 3, and then the fifth root of that is, so the fifth root of 1,024 is 4. 4 times 4 is 16. 16 minus 5 is 11. So that's how I know that that x value works. All right, so that's how we solve radicals. What if it's not in radical form? What if it is in rational exponent form? All right, what if our variable has an exponent instead of being trapped underneath a radical? How would I undo this? Okay, so think about this question that I got posed over here. Once the x is all by itself, what power could you raise both sides to so that you would be left with just x? Now, we talked about this a little bit up here with this idea of why do I square both sides to undo a square root? Well, it's because a square root is the same thing as x to the 1/2 power. Okay, so it's the same idea over here. So like in this first one, if I want to get x all by itself, I'm going to divide both sides by 4. So I'm going to get x to the 3/2 power equals 108 divided by 4, which is 27. All right, so how do I get this x by itself? What power do I need to raise both sides to? Okay, well, I need to raise both sides because I want this exponent on the x to become 1. Well, what do I multiply a fraction by to make it become 1? I multiply it by its reciprocal. All right, because 3/2 times 2/3, that's going to cancel each other out. So then I'll get x equals 27 to the 2/3 power. All right, but we've talked about how to simplify those. This is the same thing as the cubed root of 27 all raised to the second power. 27 to the 2/3 power is the same thing as the cubed root of 27 squared. So the cubed root of 27 is what do you have to multiply by itself 3 times to get 27, which is 3. So we're taking 3 squared, which is 9. All right, so this equation, our answer is going to be 9. All right, and we can always plug that back in. 4 times 9 to the 3/2. Well, 9 to the 3/2 is 27. 27 times 4 is 108. Okay, we can use our calculator to check that if we need to. All right, what about in B? We've got x plus 2 to the 3/4 power minus 1 equals 7. All right, so here, first thing we need to do is get this expression with x by itself. So I need to add 1 to both sides. So I'll get x plus 2 to the 3/4 power equals 8. So now, what do I need to raise both sides to in order to get rid of this fractional exponent? Well, I need to raise it to the reciprocal power. This is going to cancel out there. All right, so this is going to be x plus 2 equals 8 to the 4/3 power. All right, well, x plus 2 can stay as is, but 8 to the 4/3 power is the same thing as the cube root of 8, all raised to the 4th power. All right, remember, the denominator of your exponent fraction is the root, the numerator is the exponent. All right, so the cubed root of 8 all raised to the fourth. All right, well, the cubed root of 8 is 2, because 2 times 2 times 2 is 8. So I'm taking 2 to the fourth. So I've got x plus 2 equals 2 to the fourth. 2 to the fourth is 16. 2 times 2 times 2 times 2. So x is going to equal 14. Then I can just use my calculator. 14 plus 2. If I raise that to the 3/4 power, that's going to give me 8. 8 minus 1 is 7. So it works. Okay, so kind of the big summary for this whole thing is if it's already in radical form, you just need to raise both sides to an exponent. If it's in fractional form, you need to raise it by the reciprocal. Okay, what power could you raise it? Both sides to, so that you're left with just x. You raise it by the reciprocal. All right, so that's a lot of solving, a lot of different problems, but the key concept is the same. All right, so the last part for this video is some application problems. Very similar to what you can expect to see on a quiz or a test. All right, so we got the area of a triangle. Well, the area formula of a triangle is base times height divided by 2. All right, so the area of a triangle is 45.5 feet squared. Find the value of x. So we've got the base here and we've got the height. So we just need to plug in what we know into our formula. So what do we know the area of the triangle is? The area is 45.5 feet squared. So this is the area. So it's going to plug in for A. What do we know the base is? The base is the square root of 5x minus 20. And the height is 12. And this is divided by 2. So we've set this up. Now we just need to solve for x. Okay, so a couple different ways we can do this. First way is just to multiply both sides by 2. That's going to cancel these out. 45.5 times 2 is going to give me 91. So I'll get 91 equals the square root of 5x minus 20 all times 12. Okay, so this looks a little bit different. Like it might be more common to see it written like that. Okay, but either way, we can still, at this step, divide both sides by 12. Because I want to get that group in parentheses by itself. And I divide both sides by 12, that's going to cancel that out. All right, so 91 divided by 12 is going to give me a messy number. 7.583 blah, 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 blah. 3 repeating, actually. And that's going to equal the square root of 5x minus 20. So now I'm going to add 20 to both sides. So if I add 20 in my calculator, I get 27.583 repeating. This is going to equal the square root of 5x. So now my variable is trapped underneath a square root. So to undo that, I'm going to square both sides. So if I square 27.583 repeating, this is going to be, running out of room, so I'm going to go over here, 760.84, blah, 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 equals 5x. Divide both sides by 5, and I'll get x is approximately 152.17. All right, so that's how we use the area formula of the triangle. We plugged in what we know, and then we just use the solving steps. Some messy numbers there, but we can still solve. Okay? And the last one, last application problem, is that the approximate time in seconds that it takes an object to fall a certain distance is given by this formula. Suppose a parachutist falls 11 seconds before the parachute opens. How far does the parachutist fall during this time? All right, so we're given that the parachutist falls 11 seconds. This is going to be our t time. How far how far does the parachutist fall? That's telling us we need to solve for D, the distance that they fall. All right, so we've got this formula. I'm going to plug in 11 for T, and now I need to solve for D. Well, D is currently trapped inside of a radical, so in order to undo a square root, we need to square both sides. So I'm going to get 121 equals D over 16. So 121 times 16, I'll get D equals 1,936, because at this step, we need to multiply both sides by 16. All right, so D equals 1,936, and then our units on this is feet. All right, so think about that. If you jump out a plane and you got a parachute, all right, you have fallen 11 seconds, and in that time, you've already fallen 1,936 feet. All right, so this is all talking about kind of gravity that we deal with. So that's kind of cool. But those are some application problems with solving radicals. You've got a lot of examples here. So just make sure you bring in any questions you have, complete those practice problems, and make sure you're good for our quiz and test. If you need anything, please let me know. Other than that, stay safe, and I'll see you when I see you.